Okay, so for the next one, we are skipping example number 13 because that one is a bit more complex than it seems, and jumping into the first and the one and only exercise for rate of change, which is exercise number 11. So we are given a situation over here, which is sand is poured onto a horizontal floor and it forms a pile shaping like a right circular cone like this. Okay, so that looks like sand enough. Let's give it a little bit of shading to provide realism in this example. Okay, so this is the basis of rate of change. Usually we will see the question or problems involving rate of change, you will use formula with more than one variable. Just now in the previous example, which is example number 12, it is quite like SPM or high school level, which is where the cube we have V is only in terms of L. So the question is very easy. You don't have to substitute anything in terms of other thing. So that is for a very easy level. So this one, we have this particular sand over here, and you know that if we are dealing with cone, then the formula will be 1/3 pi r square h involving r and h. So this is where we will see that you need to rewrite something in other thing first before you can proceed to differentiate it. Okay, so before we write the chain rule over here, let's write whatever the question has provided us with. The volume of cone is definitely written in terms in the letter big V. So this one is volume, and then since we are dealing with R and H, so let's just mention or declare that R is radius and H is the height of the cone. Okay, so provided in the question is the rate of change or increase of the volume of the cone is going to be dV over dt. So hopefully by now you can see that we can simply write this the long sentence in the form of symbol with d and dt here. Alright, and going for the chain rule first, we are looking at rate of change of radius. So the answer is definitely the r over dt, and provided in the question is dv dt. So to complete this chain rule, we need to find dr over dv. So let's make a little cloud over here. Okay, so now finding dr over dv. So from here you can see that the relation that we are looking for is going to be differentiating v with respect to its radius r, and as we know it, the formula for volume again is going to be v equal to 1/3 pi r square and h. So you have r and you have h. So there are two variables. So please remember that we are doing a very simple differentiation here. So you need one variable only, and over to the right side is also one variable only, where we have two just now, which is r and h. So we need to do something about this h. Going back to the question, it's mentioned over there that the height of the sand cone is actually 3/4 of its radius. So from this we can say that height is and since we are using h over here, so h is equal to 3/4 of its radius, definitely 3/4. In case for examination purposes that you do not sure what does 3/4 means, usually we skip on writing this in this really general or following the grammar law of English. But if we ever give you this particular statement or sentences type, you can ask for from your invigilators the meaning only, not to help you write h equal to 3 over 4r. At least for those who are weak in English, they or he or she or they can know that 3/4 means 3 over 4, and a quarter is definitely 1 over 4, half is 1 over 2, 2 over 4, or anything else. So hopefully that is clear for you. And then our new volume. So volume is equal to 1 over 3 pi r square h, can be rewritten as 1 over 3 pi r square multiplied with 3 over 4r, and the final new expression of the volume over here will be 1 over 4 pi r cubed. Now we have v in terms of r, then we can do our differentiation with dv over dr. So I'm going to do it here. dv over dr is going to be 3 over 4 pi r squared. Okay, now we have all the information needed, hence for the final answer, dr over dt is equal to dv dt. I'm just going to substitute it directly. It's going to be 100 multiply with, so this one is r square, so for the r square we have, okay, so take a look at this one. Be very careful, because dv dr is actually for the numerator side it's 3 pi r square, the denominator is only 4. So when you write it dr dv, which is the inverted form of it, so make sure that you have you change the numerator and denominator in a correct way. So now we have r square over here, and as what I have mentioned in the previous example, this is where you will change the variable into the given value from the question. In this case, at that particular instant, is the radius is 8 centimeter. So our final answer using calculator will be 25 over 12 pi, so the pi is still there, centimeter per second. So that's it for exercise number 11.